Hi everybody, welcome back to part 2. In this episode we will concentrate on getting APT installed and configured for either a CCD or DSLR. We'll also go through the process installing and configuring Open PHD2 to enable auto guiding on your imaging runs. So let's get started. As with the last episode, I've already gone through the process of downloading all the pieces of software that will be needed for this tutorial. However, a full list and links to their download locations can be found in the description of this video. Go to my PC and go down to my download location, and here we'll see there are a number of pieces of software that we will have to go through the process of installing. The first piece of software that I'm going to get installed is PHD2. This will be our auto guiding software. I'm going to go through, we're going to choose mainly the basic defaults. Once this is complete, we don't need to read the README file, however we are going to launch PHD2. Now, under normal circumstances, we would go through the process of using the wizard. If you have a ASCOM or other dedicated guide camera set up, once you have gone through the process of installing the drivers for that camera, it should show up in this list. For the purpose of this demonstration, I am going to use the camera simulator. The message that you're getting here is one which is quite common for ASCOM connected cameras. What this will attempt to do is automatically configure PHD2 for various aspects of the camera settings, such as the pixel scale, which it has detected this time. One thing you will need to set up is the focal length of the guide scope camera that you will be using. In this instance, I will be setting it up as I would on my main setup, which uses a converted 9x50 scope, which I will set up as such. We need to select our mount that we'll be using. This we will select as we previously installed in part 1. Again, it will go through a number of things to try and make the installation and configuration process as easy as possible. Under normal circumstances, you would click yes. For the purpose of this tutorial, because I will not be using a live mount, I'm going to select no. And I will select a standard default of 0.5, which is a reasonable default setting for the HEQ5s and other Skywatcher mounts. We don't have any kind of AO installed, and we are going to create a profile name, but at this stage we will not be creating a dark library because I am using a simulated camera. If you have got to this point and you have a camera installed and was able to select it, you can at this point go through the process of ticking the build dark library. You will need to make sure that your scope and camera are covered so not to allow any kind of light leaks, and go through the process as it gives you step by step. Once we hit finish, we have the basic setup installed. At this point, the basic installation and configuration of Open PHD2 Guiding is complete. There are a few things that I will point out, however, which will make your initial session a lot easier. If we go up to the view option, we will want to display the graph. We will also want to display statistics. As a good default, here in the UK, I would recommend anything between 2 and 3 seconds on your guide exposures. This will enable you to overcome the effects of seeing conditions on your guiding as much as possible. We will then go in to connect our equipment. You will see your camera and your mount listed. We will connect to both of them, and you should then see if your mount and camera are both connected and powered on, that everything connects as it should. We'll then need to click begin looping. Once the exposures begin, you should be able to see our target guide stars. The first thing you will want to do is to select a reasonably bright star, making sure that in this box here you do not get SAT, which is saturated. We do not want to guide on saturated stars. We will then initially click on this button on a live system during an imaging run. Once the calibration is complete, it will then begin your guiding. My advice will be to allow the guiding to settle down for a minute or so before you start imaging. At this point, I'm going to stop everything, disconnect everything, and close down. This is the same process you would do at the end of an evening, making sure that you disconnect from both your camera and your mount before closing the application down. The next piece of software we are going to install is going to be APT. Click Next. We are going to use the default installation directory. Click Next. We will create a start menu and shortcut on the desktop, and we will click Install. It will also go through and install any additional pieces of software that it relies on to be able to complete. Once this is done, we will untick this box as we don't need to view the release notes at present, and click Finish. The next piece of software we will install will be our plate solving software. The first piece of software we'll install for this will be ASPS, or All Sky Plate Solver. Go through the process of installing and selecting the defaults, which are fine. At this point we will run the All Sky Plate Solver. Now this may take a little bit of time at this stage before it brings up the next dialog. Once you get this dialog box appear, it will be advising you that it cannot find the indexes required to do the plate solving. So the next step is to download the indexes that we require. We click Yes. Now there are a number of indexes that we can be choosing from. However, there is an easier way to find out what indexes we do actually require for our particular setup. Each individual setup will be slightly different, so if you don't see the same indexes highlighted in your setup as you do in this one, do not worry. We will go through the process of filling in the desired information to better be able to give the correct indexes to be downloaded. So I'm using a 650mm focal length telescope. You can retrieve some of this information from the camera. However, it is better off knowing the size of these details for future reference. I know the pixel scale that is required is 5.2, and my chip size is 1280 by 1024, and you will see that it has highlighted in yellow a number of index files that we need to download. At this point, we can just download the files required. This will take a short amount of time, depending on the speed of your internet connection. One small thing I would like to point out is that the details that we have given here are the details for your main imaging camera and not your guide camera. Once all the files are downloaded, you will be presented with the following screen. We can click OK and click Done. At this point, I'm not going to register this copy of the installation. It is free, and I do recommend you do it at some point. The initial setup for this is now complete. So we can click File and quit Exit. The next piece of software we will need to install is PlateSolve. This comes as a zip file, at which point you wish to click it, right click it and extract it. We will want to double click into it and you will see the software application. This I would put somewhere that you will remember it and that it's not going to get deleted. For the purpose of the tutorial, I'm going to right click on the extracted folder and click copy. I will then go into my PC, go into the C drive and click paste. The next thing we need to do is install the catalogues for PlateSolve. There are two pieces of software that we will need to install. First of all, we need the APM catalog installation, so we're going to double click into that. Click Next. Default installation directory is fine, however I do recommend that you make a note of where that is located. Click Install. This may take a little bit of time depending on the speed of your system. Once the installation is complete, we can click Finish. The next step is to extract the other sets of catalogues that we need. So we go into the following zip file, again right click, extract it. Again, this can take a short period of time. Once that is extracted, we're going to copy the extracted folder. And again, for the purpose of the tutorial, I will go into my computer, into the C drive, into the PlateSolve directory, and click Paste. We want to go into PlateSolve and load the PlateSolve application. In here, there are a few pieces of information that we need to set up. First piece of information that it requires is the location of the catalogue directories that we've just installed. The first set of catalogues are for the automatic plate match or APM catalogues. Select the directory as per the previous installation. And you should get a status that says OK. Next, we need to select the directory for the UCAC3 catalogues. Again, select the directory, and this one we installed in our PlateSolve directory. And again, we get the status of OK. At this point, we want to edit a few parameters to enable the plate solving to be done more efficiently. Max star size by default is set to 6. we will set this to 12. The minimum star size can be left as default. Maximum stars we want to set to 55. Detection threshold we will set to 8. And the catalogue that we wish to use is the UCAC3. One thing I will also advise on is unticking highest accuracy plate solution. And if you wish to, you can go through the process of adding in your latitude and longitude. However, this is not a requirement. You click OK. We can click out of the application. And in my experience, I have found that sometimes the application does have a tendency of not remembering all the settings initially. So what we want to do is just again go back in and double check, make sure that all the settings have been saved as they should do, which in this case it has. We can close the application down. The next thing we need to do as the final part of this episode is configure APT. I'm going to double click into APT. We are going to once again enable it on our network. We're going to allow access, and once again it will go through the process of asking us if we wish to set the coordinates for our location. Here you will find a checklist of things that you need to do at the beginning of an evening. This is completely customizable and optional. I'm going to untick the option for it to start at startup. Click OK. Here we are displayed a number of options. We need to select the path that our images are going to be stored at. You can use the default location, or you can select any path that you wish to. One option you do have is to select the default colours of the application. The next settings we're going to set up are in regards to our camera. We want it to automatically connect to the camera. If you have a colour CCD, you can select and tick the preview button. You will need to select the correct Bayer pattern for your camera. This will enable you to see colour previews as you are imaging. The next thing we need to do is select and configure our location. We have two options here. Fill the details out manually, or we can select to import the coordinates from ASCOM. For the purpose of the tutorial, I am going to import those coordinates from ASCOM and select the auto option for daylight savings as I am in the UK. The next options we can go through is to automatically connect to the mount. If you have a focuser, you can advise to automatically connect to a focuser. For the purpose of the tutorial, I'm going to leave this unticked. There is the option to have sound notifications. For the purpose of the tutorial, I'm going to leave these enabled. However, you may wish, once you have got used to using the system, to actually disable those notifications. Under the Planetarium tab, we need to select which planetarium we are going to use along with APT. In the tutorial, we are using Stellarium. The standard defaults will normally be sufficient. Under the Advanced tab, you do have a number of options to automatically connect to a DSLR if you are using one, to enable larger user interface fonts if it's easier for you to be able to see it. There is also a few options for selecting delays and asking for the object name at the beginning of a run, which I will select. The plan's start delay I normally set to around 10 seconds. At this point we can click OK. Under the Gear tab, we need to set up and choose our mount. Click Connect to Telescope, and again we are going to choose the EQ mod ASCOM driver that we used in the previous tutorial. For the purposes of the tutorial, I will use the simulator. We can click OK.
Telescope connected.
At that point, it should automatically connect to the mount if it is connected and powered on. If you have a focuser, a filter wheel or rotator on your setup, you can also connect them at this point. The next thing we want to do is go into our guide setup, and the option we are using is PHD2 Guiding, so we will select that. The default PHD locations are normally fine. Click OK. The next tab is the camera tab. Here we need to configure the camera to be connected with APT. We click Connect. We get given an option for a Canon EOS camera, a Nikon camera, or a dedicated CCD. If you are using either of these two, you can select the auto tabs and the generation if required. If you are using a dedicated camera, you can select CCD, ASCOM, or one of the dedicated driver setups. I will be using an ASCOM camera, and again I'm going to tell it to preview color images, and I will select the desired layer matrix and click OK. At this point it will bring up an option asking us to choose our camera. You should find under normal circumstances that as long as you have installed the ASCOM drivers for your camera, it should show up in this drop down menu. If you are using a Canon or Nikon DSLR, this step will not be needed and it will automatically connect to the camera. So at this point you can go through the process of setting up the camera as per the manufacturer's requirements and click OK.
Camera connected.
Once you have that set up, you can go back to the Gear tab and make sure everything else is connected up. Go over to the Tools tab, at which point we can tell APT the focal length of our scope. Once again, I'm going to enter 650mm. It will normally also automatically detect the details for your camera. This is the basic configuration for APT complete. The next bit of configuration involves the point craft and plate solving in conjunction with APT. At this point we are going to go into point craft, settings, and here we will need to give a couple of parameters to get the setup complete. We need to find the location of plate solve 2, which we previously installed. And the location of the All Sky plate solver, which has also previously been installed. The only other bits of information we need to give is if you are using a crop body DSLR, such as a 450D, 600D, or one of the Nikon crop body cameras, is to select Use DSLR Crop Factor. The default 180-second timeout function should be fine. Normally it will only take 5 or 10 seconds to do the plate solving. 5 attempts is fine. The acceptable number of pixel errors. This setting effectively means how far away the error can be in pixels to be classed as acceptable. The standard 50 pixels in this instance I'm going to leave as default. The point craft exposure setting is one that we will need to set. This is how long it is going to expose either your DSLR or dedicated camera for when taking an exposure for the purpose of plate solving. A good standard default is 10 seconds. At this point, we can click OK. The basic setup is now complete. We can click out of the plate solve option. We can also then close down APT. The basic setup and configuration of all the software required for a PC controlled imaging setup is now complete. There are a number of ways that you can go through setting up at the beginning of an evening. However, there is a basic routine that I recommend you follow initially to be able to get the system set up and running as quick as possible without any problems. If you've not already created a shortcut onto your desktop, I suggest this is now the time to do it. Just drag, whilst clicking and holding the left mouse button, the icon onto the desktop. I will go through a standard routine for starting your imaging system at the beginning of an evening. The first thing we wish to do is go into PHD2 and connect to the mount and the camera. Once that is connected, we can start the looping process and minimize. The next thing we want to do is run Stellarium scope. Stellarium will automatically load as per the previous tutorial. We can go down to the bottom here, disable the full screen view and minimize that. Minimize Stellarium scope, and last of all we double click to start APT. At this point everything is running that is needed for a complete imaging session. At the end of the evening we go through a set routine as well. First thing I would do is click into PHD2, stop any guiding, go in to your equipment and disconnect everything from PHD2 and close that down. You can now close down PHD2 as required. The next thing you can do is then close down APT. Go into Stellarium scope, disconnect from the mount. You can now close down Stellarium and exit Stellarium scope. Part 2 is now complete. At this point you have a full basic up and running imaging system that you can use. Please come back for further episodes which will look more in depth at Stellarium, APT and plate solving.